You are welcome to this presentation by Sanjay Academy on Advanced Level Physics Option 2 Communication Year 2020. Please, I would like you to hit the notification bell and subscribe, like and share so you will always get content sent notifications sent to you each time we do an upload. We will go straight into the subject matter, and we have this figure 11. We are respecting the question number on the paper so that if you have a paper, you can easily see that we're dealing with question number 9. Figure 11 shows a light signal entering into an optical fiber. It says a pulse of light is emitted by switching on the source for 10 microseconds. The light is emitted in many directions as shown. The critical angle at the core Gladden boundary is 59 and the length of the fiber is 6.0 kilometers. The refractive index of the core is 1.5. State two advantages optical fibers have over copper cables in communication. Now we have a few of them. One, optical fibers can carry greater quantity of information than copper cables since they have a high bandwidth. Optical fibers are lighter than copper cables and easier to handle. There is little interference to electrical signals with optical fibers. There is low attenuation with optical fiber, low loss of information. 9A Roman 2. Some light from the source will travel straight down the fiber for its entire length. Determine how long it will take to travel down the length. We know that we know that the speed of any moving object is the distance covered by the time. And in the case of this fiber, the distance happened to be the length of the fiber. And what we are interested at is the speed of light traveling through the fiber. So the speed of light is equal to the distance covered by that light divided by the time. If we had to calculate the time, it means that we are going to divide the speed by the distance, like so. But this is going to be the speed of the light in the Gladden. The speed of the light in the core. How can we get the speed of the light in the core? From refractive index, the speed of the light in air is equal to the speed of the light. The refractive index is the speed of the light in air divided by the speed of the light in the core. If we use symbols, we're going to have this for refractive index of the core is equal to the speed of light in the air divided by the speed of light in the core. Therefore, the speed of light in the core is the speed of light in air divided by the refractive index. If that is well done, we have 2.0 times 10 to the power 8 meters per second as the speed of the light in the core. So if we substitute distance, which is the length of the fiber, by the speed of the light in the fiber, we're going to have the time it's going to take to travel down the fiber, and it gives us 30.0 microseconds. 3. What is the refractive index of the Gladden? We are asked to calculate the refractive index of the Gladden. From Snell's law, we know that when light moves from one medium to another, the relationship is given as here, the refractive index of medium 1 times the sine of the angle of incidence is equal to the refractive index of medium 2 times the sine of the angle of refraction. It so happened that at the point of when there's a critical angle in the Gladden, then the refractive index or the angle of refraction is 90 degrees. These are the parameters that have been given us. The angle of incidence, which happens to be the critical angle, and this is the angle of refraction, and 1.5 is the refractive index of the core. So N2 is the refractive index of the Gladden. If this is well substituted, we end up with 1.3 because sine 90 is 1 and sine 59 is 0.8572. So 1.5 times 0.8572 is equal to 1.3, giving us the refractive index of the Gladden. 9b. Figure 12 shows a block diagram of a simple radio transmitter. Here we have the sound, the microphone, the audio frequency, the oscillator or radio frequency generator. Here we have the modulator, the radio frequency amplifier, and the transmitting area. Question: state the function of the microphone and the modulator. 1. The microphone converts sound waves into electrical waves. The modulator encodes the amplified audio frequency signal into a fixed radio frequency or carrier waves in a suitable way. Briefly explain the differences between amplitude modulation and frequency modulation. Frequency modulation offers a much bigger bandwidth and therefore a higher information carrying capacity. Amplitude modulation transmission offers a lower bandwidth, therefore a lower, no, this should be, please, this is a lower information carrying capacity, a lower, this should be a typographical error, offers a lower bandwidth and therefore a lower information carrying capacity. Frequency modulation has a higher efficiency of processing, while amplitude modulation has a lower frequency of processing. Frequency modulation. In frequency modulation, the transmitted information is found in the variation of the carrier frequency, whereas the transmitted information is found in the variation of the carrier amplitude for amplitude modulation. For frequency modulation transmission has a more complex circuitry, while amplitude modulation transmission has a less complex circuitry. Frequency modulation has a high signal to noise ratio, whereas it is low with amplitude modulation. For frequency modulation transmission, it generates a carrier and multiple bandwidth. It generates a carrier and multiple bandwidth, whereas amplitude transmission generates a carrier and two bandwidth. Lastly, it has a better quality and audio fidelity due to a greater bandwidth, that is, frequency modulation transmission. And amplitude modulation transmission has a lower quality and audio fidelity due to a small bandwidth. State one advantage that each of FM and AM has over the other. It means give the advantages that frequency modulation has over amplitude modulation and the advantages that amplitude modulation has over frequency modulation. Frequency modulation has a larger bandwidth than amplitude modulation. Frequency modulation can transmit the same information quality with low transmitter. Frequency modulation has a greater immunity to noise since noise is a form of amplitude variation. Frequency modulation has improved signal-to-noise ratio with respect to man-made interferences over amplitude modulation. Frequency modulation offers higher fidelity than amplitude modulation. It offers higher fidelity than amplitude modulation. Frequency modulation encoding makes it less sensitive to interferences from electrical activities from storms or other electrical devices. Now, advantages of amplitude modulation over frequency modulation. 1. It is relatively easier to detect amplitude modulation with simple equipment than frequency modulation. Amplitude modulation operates at a low frequency and has a much larger wavelength. Therefore, its signals travel further than frequency modulation because of the larger wavelength. Amplitude modulation signals travel better through solid, through hills and solid better than amplitude modulation. Lastly, amplitude modulation, modulators and demodulators are easy to build, making AM radios less costly. C. State 3 advantages of digital communication over analog transmission. Advantages of digital transmission over analog transmission. Digital transmission can convey information with less noise, distortion, and interference as compared to analog. Digital circuits can be reproduced easily in mass quantity at comparatively low cost. Digital signal processing is more flexible than analog. With digital signals, security is higher than with analog. Please, if you do enjoy this, once more I encourage you and I invite you to sign up, subscribe, click the notification button, like and share with friends. Lastly, digital signals are suitable for computing and they are suitable for digital electronics operations such as data storage, whereas analog signals are suitable for transmission of videos, audio through communication channels.